Assalamualaikum and good day everyone. This is the last example for the lead lag controller design topics. So this question asking you to design lead lag and lead PI controller. However, I will only show you how to design the lead PI controller using the plan given to improve the system response that give the design requirements. TP less than 1.5 seconds, steady state error less than 1% for step input, while keeping the percent overshoot less than 10%. So to design the lead PI controller, similarly to the previous examples, we can design it. We choose the first things is to choose the desired closed loop poles. So we know that to get about 1 second TP, we select the omega d equals to 3. So we select the S or the closed loop poles at the location -3 plus minus J3 to give the desired TP. And for example, we select 5% overshoot that corresponding to zeta of 1 over square root of 2 or 0.707. So we expect these initial targets will be degraded after we introduce zeros and poles of the lead PI controller to the system. So for a lead PI controller, we have the GC equals to KC S plus ZE S plus ZA over S plus PE and S. So we don't have S plus PA because we use lead PI controller. So when we have PI controller, we only have here S at origin. So the subscript for the E and A represent the lead and PI respectively. So let's say we follow the lead and PI controller design. Then we select the ZE equals to 3 to cancel the largest pole of the plant, and ZA equals to 1 to cancel the smallest pole of the plant. So at the closed loop poles -3 plus minus J3, we can find the angle of the resultant pole. So we can calculate the PE using the formula of the summation of zero angle minus summation of pole angle. So in this case, we have PE negative angle S plus PE minus angle of S equals to negative 180 degree, because we have designed the controller so that we can cancel out the S plus 1 and S plus 3 here. So using the formula, we can get the angle of PE at 45 degree, and from the angle we can get the PE location, which is at 6. Okay, then we can calculate the value of Kc. So the Kc, we can use the resultant from the from the multiplication of Gp by Gc, and we can get here as S plus 6 over 3.5. So we can find the value of Kc equals to 5.14. So this is our controller for that we have designed. So let's see the examples using MATLAB. So in this example, I have simplified by using, so GP, I have this one 3.5 over S plus 1 as S plus 3. However, I have simplified the steps into a function here. Okay, so I call the function lead PI. So the input to the lead PI function is a plan, and then is the value of ZE and value of ZA, and as well as the closed loop poles value. Okay, so I will get a few parameters from this function, which is Kc, PE, GC, Kp, and a steady state error. So let's try to run this function. What I get is, okay, so from this I get Kc, which is equals to 5.14, PE equals to 6 GC, which is the controller, equals to exactly as we have found in the lecture notes, and then Kp equals to infinity, thus we have the steady state error equals to 0. Okay, so we have 0 steady state error here. So we managed to get all the parameters simply by running the function here, and then we can plot seesaw tool using GP and GC that we have calculated. And what we get is actually we have the output response that equals to 4.32% at 1.04 seconds. So we can further improve the response by we try to increase the value from 5 to 7. So what we get here is we get the overshoot is 9.13 at time of 0.798. So basically, without changing the KC to 7, we already managed to fulfill all the requirements, because the TP value, the design requirement for TP is 1.5 seconds, but we managed to get 1.04 seconds previously using the default value of KC that we have calculated. So when we increase the KC value to 7, we can further increase the overshoot to 9%, about 9%, and at time 0.8 seconds. So the steady state error still maintained at 0%. So we already done all the design or specification that we need for this question. So in the next lecture, I will show you how to do the function to simplify or to reuse your codes for another example without running line by line. Okay, until then, thank you very much for your attention. See you in next video. Assalamu alaikum and goodbye.